Alright? So then I want to understand this notation. I want to represent another notation which is n of s. Okay, what is n of s means? Okay, that is to count the number of elements. Okay, so n of s will give you a number. Okay, will give you a number. S, A, and B will give you a set. Okay, a set of all the possible outcomes. It's a list of all the possible outcomes. You got it? Can I? So n of s is to count how many elements in S. Then my question is that how do you count? Okay, we're going to use 4 different techniques. Okay, of how to do counting. The first one is very simple, to just to list out. Okay, remember that last week when I talked about this, for example, the S, I want to look at the toss of the coin. Okay, if I toss the coin one time, what is all the list of the possible outcome? Only 2 outcomes, right? H or T, right? Got it? So that's what I mean by listing. Okay, listing means that if the thing is finite or the thing is small, you can basically list them out. Okay? And another example, if let's say I throw 2 dice, right? I want to make sure the sum of the 2 times must be more than 7. Then again, you also can list out. Yeah, so you can list out how many of them are there. Yeah, so that's called by listing. Okay, so when the number is small, then I can do by listing. Alright? Hello. Yeah, come. Hi. Yeah, I just revising. So okay. If the number is going to be very large, okay, when the number is going to be very large, then you cannot possibly do by listing. Okay, it's not possible. Okay, come, settle down. Okay, so if the number is very large, it's not possible to do for you to list out everything. Okay, for example, 10,000 accounts or 10,000 values, right? You cannot list all the 10,000.
Sure, can I ask one question? What if I empty tomorrow?
Then I'll do the retest for you. When? I don't know.
After school come back.
Yeah, maybe next week. Yeah. Are you planning MC tomorrow?
No lah.
No lah. Okay, then
I
okay.
feel a bit sick. You see, feeling sick.
Oh, okay. If you must get an official MC. Yeah. Okay. Can we talk about the test maybe later? No, let me finish this thing first. Okay. And then we'll talk about that during the break. Yeah. So this is topic 7. All right. So in here when you say listing, when the take note, when the sample space is small, then you can actually list out no problem. If the sample is very large, okay, for example, I got 23 of you here. I want to choose 4 of you to be the class committee, in the class committee, for example. Can I go list out all the possibility? Not. If I want, I can, but it takes a lot of time. Yeah, so then I need to use something called a counting principle to do it. Alright? So counting principle have been done in topic 6 already. So I don't want to come here and talk about this here. So you already done it in the previous topic, okay, so you can use that to do it. You can also convert your data into a table. Remember, you also can convert in a table. Use your table to do your counting. Okay, and finally, you can also construct a tree. Okay, later, this one you don't see it that much at this point yet. Okay, but later I give you some examples. You'll see more trees in action. So these are all the ways you can do determining the elements, okay, inside your S, okay, with n of S. Yeah. So why is this so important? Okay, because once you get to know the number, then you can use this to calculate the probability. Alright? So how do I define probability? Very simple. I just need to define the probability of A equals the number of elements in my set A divided by the number of elements in my global set, okay, with my set S. Okay? So that becomes my probability. Yeah, and because of that reason, right, and I know AB is a subset of S, right? Then I know the probability must always be between 0 and 1. Okay, got it? So this one is very important concept you need to know. So once you calculate a value of probability, it must be between 0 to 1. Okay, anything that's less than 0 or anything that's more than 1, then you are wrong. Okay, the probability is always between 0 to 1. Okay, by all the definition that you have, right? This one is always that. Okay? So then what happens is that then we take a look at the concepts of if I find counting of a set A is difficult, sometimes it's easier to count the complementary of A. That means not A. Okay, so sometimes it's easier to do that. So you want to do that, then the probability of A prime, which is not A, is equal to 1 minus the probability of A. Yeah? Why is that so? Very simple, right? Because A union A prime will give me S. Okay, and then you just divide by n of S throughout. So you'll get this formula. Okay. Then we have two event A and B, right? This is important, huh? So this is a formula that relate how these two events actually interacting with each other. Yeah. So the probability of A union B, that means the whole shaded region. Okay. Okay, come. That's not right. Equals to probability of A plus the probability of B. But if you do that, what will happen? You'll find that your intersection get counted twice. Okay, so then what you do, you need to subtract away your intersection. Can you see that? If you take probability of A, you already include the intersection, right? Then you take another probability of B. That means the intersection, the common region, you counted it twice. Okay, so you see you counted it twice, you have to minus away one away, right? So then you get an A union B. Got it? Clear? Okay, so then from that, okay, from once you understand this, then we define another thing called conditional probability, meaning that I want to find the probability of A given that some event have already occurred. Let's say the event B have occurred. I want to find the probability of A. Come, Louis. Hey, come, look the front. Don't look at your friend first. Huh? No need one. Don't go and disturb your friend. You don't need your friend needs. Okay? Don't disturb your friend. Okay, so probability of A given B means that I want to find the probability of A given that B have already occurred. Okay, so how do you find the probability? You just use this formula. Yeah? So it's probability of A intersect B divided by probability of B. So okay? Can So then what will happen is that last week I concluded with this one. Okay? When A and B is said to be mutually exclusive, means what? Means that they have no intersection. Okay? So that's why the intersection is equal to 0. Okay? So if the intersection is equal to 0, if you're going to substitute back into this formula, right? You're going to substitute this one back into this formula. What you get? You get this, right? Probability of A union B is equal to probability A plus probability of B. You got it? If you substitute this one back into this equation, right? So you know that this is gone, right? So the probability of A union B equals to probability A plus probability of B. Okay, so this looks like additive principle in counting principles, right? Looks like that, yeah? But take note, this one have a condition. The condition is that A and B must be mutually exclusive. Okay, that means there's no common intersection between the two events. Alright? And the last thing which I not covered today is called independent. Okay, that means one do not depend on the other. Okay, so then you have this set of things. So I'm not covered this. Okay, I put it here for you, which I'm going to cover now. Yeah. And any question? This is a summary, okay, of what topic 7 is about. Any question? Clear? Yeah. Okay, good. So if not, then let's move on. Can you see without off the light? Okay, I can see. Okay. So the next thing I want to talk about is called independent event. Okay. What do I mean by independent event? Means that one do not interfere with another. Okay. So more obvious is this. So once I say they are independent, okay, once I say they are independent, straight away I know this is true. Okay, so in fact I don't quite like these notes. This will come first. Okay, so this will come first. Okay, as I told you, right? If two events are independent, means what? The probability of one event do not interfere of the probability of another event. Yeah? So which means what? Which means that I want to find the probability of A given that B have occurred. But A and B are independent, right? So I don't really care if B have occurred or not, right? I just need to know the probability of A. So that's why if these two are independent, then the conditional probability is just the probability of itself. Okay, which means that probability of A given B is equal to probability of A. So what I mean? Yeah, so I prefer to do this first. You do this first. Okay, once you do this, then you break this up using a formula. Okay, what is P given what is P? Then you ask yourself, what is this, right? What is P A given B, right? This one equals to probability of A intersect B divided by the probability of B, right? So this one I do nothing. What I do, I just apply the formula, okay, that I have covered last week. Okay, so once I have done that, then can you see straight away I know that this one, because since these two are independent, I know this one is a probability of A, right? Now can you see what I'll do? I just bring this over. Then the probability of A intersect B is equal to probability A times the probability of B, which is this one.
Huh? When did email?
Got it? I don't know, get so distracted with other things. Better listen to this because this one will come out in your second test. Okay, so make sure you understand how to do it. Huh? No, thank you. Okay, so in this case, when we bring this over, straight away you get that equation above. So probability A intersect B equals the probability A times probability of B. So can you observe some similarities between counting principle or not? Counting principle, we call this as what? We call this as multiplicative principle. Okay, that means when things happen must happen together, I do multiply them together, right? But in terms of probability, just take note now. You can only multiply the probabilities if they are independent. Okay, very important. If they are not independent, then you cannot multiply the probability like that. You cannot.
Why?
Why? Because probability A given B is not probability A. That's the reason why. You got it? Yeah, it's not coming tomorrow, but it's coming out in the final test. Yeah. So, listen up, because I think this final test is another 20%. This test is 10% only. Tomorrow is only 10%. Okay, so
that's future Louis problem.
yeah,
That's future Louis problem.
that's future Louis problem. I let you, but again, I cannot hold because the test. Then everything can hold back. I cannot hold. I need to move forward. Yeah. Got it? Okay, so that is very important. So as long as A and B are independent, then I know that the condition probability A given B is probability of A. Then I substitute back into the formulas that's given by this one to get this probability of A intersect B equals to probability A times probability of B. Are you all clear? 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 Very important, so you must make sure you understand this. Okay, good. Then what will happen is that you want to check out whether the two events are independent. Then what do you do? Very simple, right? You need to check. I define A as selecting a king without replacement, B as selecting a queen without replacement, right? So what's the probability of B? The probability of B is, I have how many queens in my deck of cards? I got 4 queens, right? Because there's 4 different types of queen, right? 4 queens. Out of deck of cards of 52 cards. So it's 4 over 52. Got it? Then what is probability of B given A? Okay, that means if A have occurred, that means what? I have already selected a king, right? I already selected a king. So just take note, right? It's without replacement, right? So how many cards have I left in the stack of cards? It's no longer 52, it's going to be 51. Are you following me? 51. Yeah? So, but how many queen I have? I still have 4 queen, right? Because the one that's selected is not a queen. The one selected is a king, right? Because A is selecting the king, right? So I still have 4 queen inside there. But the number of cards I have, or how many cards I do I have now become